Hi and welcome. In the previous video, we have seen a hash function of mod 10, correct? Now, what this function can create a problem. Since we are mapping a larger set of values, see we have a universal set of values of 0 to 999 and we are mapping it to just 0 to 9, just 10 index. So, there is a good chance that different numbers might map to the same slot index depending on the hash function that we are using. So, for example, it is nothing but 11, 145, 555, 156 and 756. Now if we are using a mod 10 function, 11 will be mapped to 1, 145 and 555 will be both mapped to 5, and 156 and 756 will be both mapped to 6. Okay, and if we are starting with our array from this direction, so 555 will be overwriting 155 in our hash function, because first at index 5, 145 will be stored, then 555 will override it, so we will be losing some of our values. This condition is known as collision. Okay, so when many values map to the same slot index, that condition is known as collision. Fine, now we need to come up with the solutions of collision that we will be seeing in the further videos. In this video, let's see one of those solutions, and that is nothing but choose a better hash function. Now choosing a better hash function will not give you 100% guarantee that yes, all the values will be sorted, all the values will be uniquely mapped. Okay, but it is one of the solutions. Okay, so let's see how we can identify, how we can choose a hash function. Okay, so let's see these points. So given a collection of elements, a hash function that maps each item to a unique slot is referred to as a perfect hash function. Practically it is nearly impossible to have a perfect hash function. Okay, there will be some collisions. So how to choose a good hash function? So an efficient hash function should be designed so that it distributes the index values of inserted objects uniformly across the table. Okay, so when we have a table, so the object should be uniformly distributed. There should be as less of collisions as possible. An efficient collision resolution algorithm, we will be seeing about these algorithms, should be designed so that it computes an alternative index if there is a collision. Okay, we'll be seeing about these algorithms now. We must choose a hash function which can be calculated quickly, returns values within the range of the locations that we have, that is nothing but 0 to 9, and minimizes the collision. So these three are the characteristics: minimize collision, be quick to compute, and distribute the values evenly in the hash function. Now what we are going to see is, we are going to see the code, and there are some changes in that code. So first we will see a mod 10 code which we have already seen with these values, and see how the collision is affecting the answers. Then we are going to change it to a prime number mode. Okay, so it is an improved version of this mode, but it also have collisions. We will see about that it is improving, but it is not a perfect one. Okay, so let's see the coding part. So let's see how collisions affect the answer. So in this particular case, we have 11 and 141 that will definitely collide because of mod 10 function that we are using. These three values will definitely collide because the 6 is the answer for all these three values. Okay, so 141 will override 11 and 296 will override these two. So finally we will just have three values inside our hash, that is nothing going to be printed, but actually we have 6 values. Okay, so we are going to improve that. So let's see a better function. Let's use a prime number. Okay, so using a prime number generally is preferred because it has more even distribution. Okay, so now let's run it and let's see if it improves the performance. I'm not saying it is a perfect hash function because practically it is not possible, but yes, it does improve the performance. Now it is printing 5 values instead of just 3 values. In the next video, we are going to see about the collision resolution algorithms, and let's see how they improve this part. Okay, thank you.